Hello children, good morning everyone. How are you all? Hope you all are fine. Very good, you are doing your homework. Some children are not doing the homework. Okay, you should do your homework regularly. Why we are telling to do the homework assignments? Because it will be considered for your mark. Okay, the quarterly exam, no, does not taken place. So for putting the mark in that, we are telling you to write the homeworks and assignment. Okay, so you have to write the assignments and homeworks properly. Okay, then only you will be given marks. Okay, we are telling for your benefit only. Okay children, do all the homework which each and every teachers are giving. Okay, you have to write 10 one words daily. That is your homework. I am also giving you classwork, assignment, etc. Okay, you have to do everything. Okay children, okay, study well. Okay, how are you all? Very nice, very good, very good. Okay, in previous class what we have studied? Scattering of light. What are the types of scattering? Okay, Raman scattering, Mie scattering, and the types of lenses. No, what is convex lens, concave lens, and the types of lenses like that. Okay, convex lens is a lens which is bounded by a spherical surface. Okay, means what? It is thicker at the center than the edges. Centerல thick-ஆ இருக்கும், edgesல thin-ஆ இருக்கும். அதுதான் convex. What is concave? Concave வந்து centerல thin-ஆ இருக்கும், edgesல thick-ஆ இருக்கும். Okay, that is diverging. Convex lens is converging lens. Okay, if we pass a light, it will converge. But in concave lens, it will diverge. Okay, these are the two types of lenses. Now, we are going to see about the images formed due to refraction through a convex and concave lens. Okay, images formed due to refraction through convex and concave lens. Okay children, okay, first of all, when an object is placed in front of a lens, okay, first of all an object is placed, okay, an object is placed in front of a lens. An object is placed in front of a lens. Okay, right? Are you putting the words in your mind? Right. The light rays from the object falls on the lens. Okay, the light rays from the object falls on the lens. The position, the size and nature of the image formed can be understood only if you know some basic rules. Okay, there are three basic rules. You have to listen carefully. What is the first rule? Okay, see the picture. Okay, see the picture. The first one is what? Sorry. See, there are two lenses, isn't it? The first one is convex lens, which is thicker at the center, thinner at the edges. Second one is the concave lens, that is thin at the center, thick at the edges. Okay children, do you understood? Right. Now, see, when a ray of light strikes the concave lens or concave lens, convex or concave lens obliquely. What is obliquely? See the red line, that is the oblique nature. Means it is not a perpendicular, not a parallel, but in a slanting, no, the line is slanting. So that is a oblique. So it is oblique to its optical center. It continues to follow its path. Without any deviation. Okay, without any deviation. See in the both pictures, there is a convex lens and concave lens. Now a ray of light strikes the lens. Okay, ray of light strikes the lenses and it continue in its path. Okay, and the ray of light எப்படி அந்த center of focus ல எப்படி pass ஆகுதோ அதே மாதிரி straight line வெளியே வருது. Are you seeing? That is oblique in nature. This is the first rule. Okay. Now, what is the second rule? See the picture. the rays passing parallel to the optic axis. Okay, rule 2 and 3, okay, both are here. Okay, first the second rule I am telling. See the first picture, concave and convex lens are there. When the rays parallel to the principal axis, okay, the rays are parallel to the principal axis, it strikes a convex or concave lens. It strikes a convex or concave lens. The refracted ray are converged. See, first picture la and the light pass ஆனோனே எங்க வந்துருது, அது கன்வர்ஜ் ஆகிருது. கன்வர்ஜ் அப்படின்னா ஒரு இடத்துல குவியிறது. ஓகே, ஸோ சென்டரில் இருக்கிறது தட் இஸ் வாட், பிரின்சிபல் ஃபோக்கஸ். அந்த சென்டர் லைனில் வந்து என்ன ஆகுது, குவியுது. அப்படி பேரலாக வந்துட்டு இருக்கிற லைட் வந்து பிரின்சிபல் ஃபோக்கஸில் வந்து குவியுது. பட் அதுவே கான்கேவ் லென்ஸில் பார்த்தோம்னா அந்த லைட் வந்துட்டுருக்கு, அது எங்கே போயிடுது, குவியாமல் டைவர்ஜ் ஆகிடுது. திஸ் இஸ் த கன்வர்ஜ் டைவர்ஜ். டு யூ அண்டர்ஸ்டுட்? இன் த ஃபர்ஸ்ட் பிக்சர் ray of light passing through the lens and it is converging. In the second one, ray of light is passing and it is diverging. It is diverging. Okay, now rule 3. See the rule 3. When a ray passing through a convex lens, first of all the ray is passing through a convex lens. What happens, the principal focus strikes a concave lens. It will be parallel. Okay, இங்கேயும் ஒரு லைட் பாஸ் ஆகுது, பட் இட் இஸ் parallel to the principal axis. சென்டரில் இருக்கிற அந்த லைன் தான் principal axis. ஓகே, இப்போ தேர்ட் ரூல் என்ன சொல்லுது அப்படின்னா, ஒரு ரே ஆஃப் லைட்டை பாஸ் பண்ணோன்னா அது என்ன ஆகுது, அந்த பிரின்சிபல் ஆக்சிஸ்க்கு பேரலாக பாஸ் ஆகுது. ஸோ when it is passing parallel to the principal axis, that is third rule. Okay, again see the concave lensல பாரு, ஒரு ray of light pass ஆகுது, அது parallel-ஆ what happened, it is refracting. Okay, these are the second and third rule. What is happening, when the rays parallel to the principal axis strikes the concave or convex lens, the refracted rays are converged in convex lens and diverged in concave lens to the principal focus. Third rule, when the ray passing through a convex lens or directed towards the principal focus, it strikes a convex or concave lens. Now the refracted ray will be parallel to the principal axis. The refracted ray will be parallel to the principal axis. Okay children, have you understood? Right. Now refraction through a convex lens. See, this is the convex lens. Okay, now let us discuss the formation of images by a convex lens. Okay, formation of images by the convex lens when the object is placed at various position. What happens? Okay, when the object is placed at various position, okay, what are the formation of images are there in the convex lens? Let's see one by one. First of all, object at infinity. Object at infinity. Okay, means infinity means it is unaccountable. Okay, infinity means more. Okay, so when an object is placed at infinity, real image is formed at the principal focus. The size of the image is much smaller than that of the object. Okay, see, this is the convex lens. There are uniform rays of lights are passed. Okay, what happens, எல்லாமே ஒரே இடத்துல குவியுது at the point F2. Okay, each and every one is going at the same point and got diverged. Okay, converge ஆகி அப்புறம் diverge ஆகுது. Okay, parallel beam of ray of light pass ஆகுது, அப்புறம் சென்டரில் போனோடனே converge ஆகி அப்புறம் diverge ஆகுது. This is object at infinity. Now, okay, this is the object at infinity. So here the size of the image is smaller than that of the object. So இந்த இடத்துல இருந்து நம்ம பார்க்குற அந்த ரியல் இமேஜை நம்ம பார்க்கணும் அப்படின்னா சைஸ் ஆஃப் த இமேஜ் எப்படி இருக்கும் அப்படின்னா ஸ்மாலராக இருக்கும். ஆப்ஜெக்டோட சைஸை விட இமேஜோட சைஸ் இஸ் ஸ்மாலர். ஓகே, now when the object is placed beyond C, that is greater than 2f. Okay, See the principal axis, there is a point to F1, F1, F2 to F2. Okay, the object placed beyond C. Okay, when an object is placed behind the center of curvature, a real and inverted image is formed between the center of curvature and principal focus. Okay, when an object is placed behind the center of curvature, beyond C. Okay, what is the center of curvature? It is beyond C. Okay, so when the object is placed behind the center of curvature, or real image form ஆகும், or inverted image form ஆகும். Okay, see the picture AB. Okay, AB ங்கிறது ஒரு image. அதுவே அந்த லென்ஸ்ல பட்டு அங்க போகும்போது inverted image கிடைக்குது, BA. See that BA arrow இந்த மாதிரி இருக்குதா left sideல, right sideல பாருங்க BA, it is an inverted. So from this we come to a conclusion that a real and inverted image is formed. Form ஆகிறது ஒரு real image தான், but it is an inverted form between the center of curvature and principal focus. So the size of the image is same. Here size of the image is same as the size of object, but at object of infinite what happens? Size of the image is much smaller than that of the size of the object. Okay, now object placed at C. What happens when an object is placed at C? So when an object is placed at the center of curvature, okay, object is placed at the center of curvature. So what happened? A real and inverted image is formed at the other center of curvature. Here also see AB, there BA, that is a inverted image. Size of the image is same as size of the object. Okay, size of the image is same as the size of the object. This is object placed at C. Okay, now what happens when the object placed between F and C? So when an object is placed in between the center of curvature and principal focus, so F is the principal focus. Okay, F is the principal focus. A real and inverted image is formed behind the center of curvature. So the size of the image is bigger than the size of the object. Okay, when an object is placed at the principal focus, what happens? When the object is placed at the principal focus, real image is formed at infinity. Real image is formed at infinity. So the size of the image is much larger than the size of the object. So when the size of the image is much larger? When the object is placed at the principal focus. Okay, now when the object is placed between principal focus and optical center, okay, when it is placed between principal focus and optical center, a virtual image is formed. Okay, a virtual image is formed. So size of the image is larger than the size of the object. Okay, now what are the application of convex lens? Now here we have seen about convex lens. Okay, after that we are going to see about concave lens. Okay, refraction through convex lens we have seen. There are three basic rules. Okay, what are the three basic rules? The first rule is when a ray of light strikes the concave lens, or when a ray of light strikes a concave lens obliquely at its optical center, it continues to follow in its path. Okay, this is the first rule. What is the second rule? When rays pass through the principal axis, it strikes the lens and it is refracted rays are converged in convex lens and it is diverged in concave lens. Okay, what is the third rule? When the ray passing through the concave or convex lens, principal focus strikes the lenses, the refraction will be in parallel. Okay, so now what are the application of convex lenses? The convex lens bulges at the center. Okay, see the picture. The convex lenses are bulged at the center. Now the convex lenses are also called converging lenses. Convex lenses are also called as converging lenses. So this means that they refract light towards a single point. They refract light rays towards a single point. Okay, the point at which the rays cross over is determined by the distance between the lens and the light source. Okay, what are the uses? They are used as a camera lens. Okay, have you seen camera? Yes, in camera lenses we are using convex lens. Okay, it is a very important one word. Okay, it is convex lenses are used as camera lenses. Okay, they are used for magnifying lenses. Have you seen magnifiers? Yes, in magnifier lenses also it is used. Okay, and they are used for making microscope, telescope, projectors, etc. Microscope, telescope and projectors. Okay, and they are uses for glasses for far sightedness, doorathu parvai. Okay, the children or the persons who are having long sight problems, no. So to correct the defect of vision, that is called hypermetropia. Okay, for that purpose also convex lens are used. It is used in the eyes also. Okay, these are the uses of convex lens. Now, concave lens refraction. Refraction through concave lens. Okay. Now, let us discuss the formation of images by a concave lens when the object is placed at two possible positions. Okay. First, object at infinity. Object at infinity. When an object is placed at infinity, see the picture. When the object is placed at infinity, the virtual image is formed at the focus. Okay, the virtual image is formed at the focus. The size of the image is much smaller than that the size of the object. Here, size of the image is smaller. Size of the image is smaller than the original object. Okay. Now, this is at the object at a certain distance. Okay. Further, object anywhere on the principal axis at a finite distance. So, when an object is placed at a finite distance from the lens, okay, from the lens to a certain distance, a virtual image is formed between the optical center and the focus of the concave lens. Okay, the size of the image is smaller than the size of the object. Size of the image is smaller than the size of the object. So, but as the distance between the object and the lens is decreased, the distance between the object and the lens is decreased, the lens keeps on decreasing. So, the distance between image and the lens keep on decreasing. Further, the size of the image formed increases as the distance between the object and the lens is decreased. Okay, these are the refraction through concave lens. Now, what is concave lens? I already told you that concave lens is one which tapers inwards at the center. See the picture here. The concave lens is what? Thicker at the edges, thinner at the center. Okay. Now, the concave lenses are also called diverging lenses. Concave lenses are also called diverging lenses. This means the lens refracts light away from a single point. Okay. This means the lens refracts light away from a single point. Okay. What are the uses? Concave lenses are used as eye lens of Galilean telescope. Have you heard about Galilean telescope? In Galilean telescope, the eye lenses are concave lenses. Okay, they are used in wide angle spy hole in doors. In some doors, there is a spy hole. No, have you seen? Some doors there is a spy hole. In cities, maximum the doors are with spy holes because always the doors are closed in the cities. If some persons come inside, they used to see through that spy holes and only they can open the doors. So, for that purpose, concave lenses are used. Okay, they are used to correct the defect of vision called myopia for short sight. Okay, short sight. Convex lenses for long sight and concave lenses for short sight. Okay. Now, what is lens formula? What is lens formula? Like spherical mirrors, we have lens formula for spherical lenses. Okay, the lens formula gives the relationship among the distance of the object u and the distance of the image v and focal length f. Okay, focal length is denoted as f, distance of the object is denoted as u, and distance between the images v. So, 1 by v minus 1 by u equal to 1 by f. Okay, 1 by v minus 1 by u equal to 1 by f, where v equal to distance of image from optical center of the lens, where u is the distance of object from optical center of lens, and f. Okay. This lens formula is applicable to both concave and convex lenses. Okay, 1 by v, write it down, 1 by v minus 1 by u equal to 1 by f. Okay, it is applicable to both convex and concave lenses. So we need to give a utmost care while solving numerical problems. Okay, while solving numerical problems related to lenses and taking the proper signs in different quantities. Okay, we are using this lens formula. Okay. Now sign convention. Okay, what is sign convention? Cartesian sign conventions are used for measuring the various distances in the ray diagrams of spherical lenses. So according to Cartesian sign convention, the object is always placed on the left side of the lens. Okay, object is always placed on the left side of the lens. Okay, all the distances are measured from the optical center of the lens. Okay, all the distances are measured from optical center of the lens. Okay, in the lens, every time the distances are measured from the optical center. The object is always placed on the left side. Okay, எப்போவுமே லென்ஸோட லெஃப்ட் சைடில் ஆப்ஜெக்டை பிளேஸ் பண்ணுவோம். செகண்ட், ஆல் த டிஸ்டன்சஸ் ஆர் மெஷர்ட் ஃப்ரம் ஆப்டிக்கல் சென்டர். ஆப்டிக்கல் சென்டரில் இருந்து தான் எல்லா டிஸ்டன்சஸையும் we are going to measure. Okay. Third one, the distances measured in the same direction as that of incident light are taken as positive. Incident light means that is positive. Distance measured in the same direction of incident light are taken as positive. So what happens? Simultaneously, the distance measured against direction of incident light are taken negative. Okay. Against the direction, same direction means positive. Against the direction, which is opposite direction, then it is a negative. Okay. Further, the distances measured upward and perpendicular to the principal axis is taken as positive. Okay. And the distances measured downward and perpendicular to the principal axis is taken as negative. Okay, these are the sign convention. See the picture. Direction of incident light in that direction. So the distance towards left, distance towards right. Okay, that is the concave mirror. Image is placed in the left side. Okay, object is placed always in the left side. Okay, height is upwards and height is downwards is given there. Okay. The object is always placed on the left of the mirror and light from the object falls from left to right. Okay. And all the distances parallel to the principal axis is measured from the pole, and all the distances measured to the right of the pole are taken as positive. Further, all the distances measured to the left of the pole are taken as negative. The height measured upwards perpendicular to the principal axis is taken as positive. The height measured towards downward, okay, that perpendicular to the principal axis is taken as negative. Now, magnification of lens. What is magnification? So, like spherical mirrors, okay, in spherical mirrors we have magnification, and for spherical lenses we have magnification. That spherical lenses produce magnification, and it is defined as the ratio of the height of the image to the height of an object. So, magnification is denoted by the letter M. Magnification is denoted by the letter M. Okay. It is if the height of the object is taken as h, height of the image is taken as h dash. Okay. So, the magnification M equal to height of the image by height of the object. Magnification M equal to height of the image by height of the object. Height of the image is taken as h dash, height of the object is taken as h. Okay. Further, as it is related to the distance of the object and the distance of the image v, so M equal to distance of the image by distance of the object. So, minus v by u. Okay. So, if the magnification is greater than I, if the magnification is greater than 1, okay, answer is 1, or it is greater than 1, then we will get a enlarged image. On the other hand, if the magnification is less than 1, then we get diminished image. If magnification is greater than 1, then we get a large image. On the other hand, if the magnification is less than 1, the answer, okay, less than 1, then we get a diminished image, okay. Remember the formula. Now, lens make a formula. It is an equation, okay. All the lenses are made up of a transparent material, okay. Do you know now? Yes, all the lenses are made up of transparent materials, okay. Any optically transparent material will have a refractive index, okay, refractive index. And the lens formula relates the focal length of a lens with the distance of the image and the object. So, for maker of any lens, knowledge of radius of curvature is required. We should know the radius of curvature. See that R1 and R2, that indicates the radius of curvature. So, the refractive index of the given material of the lens and the required focal length of the lens, there is a equation 1 by f equal to n minus 1 into 1 by R1 minus 1 by R2. N minus 1, okay. You can also take n as mu. That means that n or mu, which is a refractive index, and R1 and R2 are the radius of curvature of two faces of the lens. There are two faces of the lens. So, that R1 and R2 are the radius of curvature of the two lenses, okay. F is what? F is the focal length. Okay, children, have you understood? Now, power of lens. What is the power of a lens? When a ray of light falls on a lens, okay, ray of light is falling on a lens, the ability to converge or diverge these light rays depends on the focal length of the lens. So, this ability of the lens to converge or the ability of the lens to diverge is called power, okay. Ability of lens to converge or diverge is called power. So, the power of a lens can be defined as the degree of convergence or divergence of the light ray. Hence, power of lens is numerically defined as the reciprocal of its focal length. So, P equal to 1 by F. F equal to 1 by P. The SI unit of power is diopter. The SI unit of power of a lens is diopter. It is represented by the symbol D. So, if focal length is expressed in meter m, then the power of lens is expressed in D. Thus, 1D is the power of a lens. So, it is 1D. What is that? What is D? Diopter. So, the SI unit of power is diopter. You should remember the formula of a lens, okay. P equal to 1 by F, okay. It will use in problems for solving problems, okay. What is the SI unit of power? It is diopter. So, 1 diopter is the, what is 1 diopter? 1 diopter is the power of a lens, focal length 1 meter, whose focal length is 1 meter. So, 1 diopter means it is the power of a lens whose focal length is 1 meter. The power of a convex lens is positive and the power of concave lens is negative. Okay, children? By convention, the power of convex lens is taken as positive, whereas power of concave lens is taken as negative. Now, what are the differences between convex and concave lenses? Okay, let me tell you the difference between convex and concave lenses, okay. The concave lenses are thinner and flatter in the middle. Concave lenses thin, flat in the middle, causing refracted light rays to diverge, okay. What is convex lens? Convex lens is thicker and rounder in the middle, causing refracted light rays to converge, okay. First point, convex lens is thicker in the middle, concave lens is thinner in the middle, that's all. Second is convex is converging, convex, so converging, okay. Convex converge, concave diverge, okay, and it produces real images. Convex produce real image, convex real image, and concave produce virtual image. Concave produce virtual image, okay, and convex for treating hypermetropia. Convex to treat hypermetropia, okay. What is hypermetropia? That is long sight, okay. Concave lenses used to treat myopia, short sight, okay. Okay, do you understood, children? These are the differences between convex and concave lenses, okay. Now it's time for your homework, okay. You have to write 10 one words from this topic, okay. 10 one words from page number 20 to 23, okay. Now you have to write assignment in 2 questions, very easiest, okay. Application of concave and convex lenses. Application of convex and concave lenses, and you have to write the difference between convex and concave. Difference between concave and convex, okay. Write these 2 questions as assignment, and the first, that is 10 one words, as a homework, okay children. Write it daily and regularly. Maintain a note for homework, and you write the assignment in A4 sheet and make it as a file, okay. Have you understood, children? Study well, okay. Don't waste your time. Thank you.